Okay, welcome, people of Earth, to day 24 of Advent of Code. Um, I don't actually have reflections on day 23 because I haven't watched those videos back. So I think I'm going to put off on any of these reflections until the whole thing is over and then do some kind of wrap up because I think the point of the reflections is that you get better as a result of realizing what you did badly on the day before. I think it's pretty clear I'm not going to get better for the next 2 days. And the way to perform better, sorry, I should engage my focus mode. Um, and the thing that will help me the most is just kind of being a little more rested and not spending so much time on this. The last 2 days, I didn't actually do when they came out. I did the following morning, and frankly, enjoyed that a lot more. And that is what Advent Dakota is really about. So I do reserve the right to, you know, on this live stream, I will read the problem. I'll see what I think of it. But I might decide that it would be more fun for me to do it on my own, and I'll still take video if I decide to do it tomorrow morning. But that might happen. So, um, anyway, so let's see what we have going today. Here we go. Okay, I guess we're gonna build a machine. Hi there. Okay. I don't. I don't understand the input instruction. Where is the input being read from? Hold on. Once you're built, you can install it. The largest vowel that can. Ooh. Oh, so the trick here isn't just building the thing. So man, largest vowel. So you certainly can't search the things. Um, how long is it? Oh, it's quite a long program. Oh my. Um, let's open it in something with a black background because that is definitely going to help us. Okay, and I guess I'll make it big for you. So, okay, multiply x. Actually, you know what we're gonna do? Because I'm gonna annotate this program so I can understand what the heck it's doing. Multiply x by, and this doesn't even multiply the value of a by b. Okay, x equals 0. These are all, this is noise. This is all noise. Here we go. So x is 13. Read an input value and write it into. Okay, that's false because w has to be between 0 and 9. So now x equals 1. Oh no. Okay, equal x 0. Sorry, what are we? So that's false. So where's the equal? If the value or equal, store 1. So 0. So these are irrelevant. X is still 0. Y is still 0. Y is 25. So that makes, so now y is 1. Z remains 0. Ugh, y goes back to 0. This is all, I must be missing something. Okay, so now, but x is 0. So all this is nonsense as well. What? I must have missed something because it wouldn't make any sense. So the first digit doesn't matter, is what I have concluded so far, perhaps incorrectly. How many lines do we have in the whole thing? So I'm really going to do this whole darn thing like this? What's the point? But maybe I will. Okay. Okay, so these are all zeros. Zeros. And, yeah, x is 13. Read an input and write it to value. Give it an integer value of at least 1 and at most 9. Okay, so no. So x is 0. X is 1. Y is 0. So x is 1. Y is 25. Okay, that's irrelevant. Y is 26. Z is 0. Y is 0. Okay. Okay. Y equals digit 2 plus 16. Z equals Y. Okay. Yep. X is 0. Oh no. So x equals digit 2. Wait, what were we doing? Okay. X equals Z. 6. That's relevant. Plus 10. And what is W? That's never going to be true because it's going to be more. So x is 0 again. What? What? Well, I do fear that I am an idiot. 1. And then we lose y. Y is 0. So, okay, so z is digit 2 plus 16. Y equals 25. It's irrelevant. Equals 26. Z times Y. Okay. Z. Oh. And then this becomes irrelevant. Okay. Y0 add. So Y equals digit 3 plus 4. I still feel like the first digit, is it really? Oh, digit 3 plus 4. Okay. Ditch that. X is 0. X is, okay. Z percent 26. That's irrelevant. Plus 15. X is W, but it's plus 15, so it can't be. And then we lose. We just lose it again and it goes back to 0? Yeah. Then y equals 0. We still have z hanging around. Y is 25. Y is 0. Y is 1. Z times y. Y is 0 again. Okay, y is digit 4 plus 14 times 0, so it's 0. Y plus 14 times 0. Add does nothing. So we lose digit 4 as well? What the heck, man? I must be screwing up. Add x to z. Okay. Ooh. X equals all this. Mod 26. Whereas z equals this divided by 26 minus 8. So that could be a thing. So now we've hit our first. Okay, we've hit our first branch. Darn. So, but then what happens here? Add y1 multiple 0 multiply. So that resets y. So it will leave some valid. It will leave something. So, okay, so that's, so digit 3 plus 4 percent 26 minus 8. So, what can we do? How much do we have? 184. So we're really just going to keep doing this by hand to get all the way to the end. That's going to be tedious. So should we write a program to do this, or should we just do 180 more things? We've done, what, 50 or so far? So, okay, let's write a program because that's what we do. Split on white space. Oh. Okay. Okay. Switch L0. So let's. Is W ever given as anything other than? No, so W is only ever used as a parameter. It's never assigned anywhere other than the input. So that's good to know. Okay. What should we do with our, okay, add a B. Um, so let's what are we doing? Uh, I'm still torn between just doing it by hand and coming up with some thing here, but we've hit a branching point and we have a ways to go, so I assume there will be more branching points. Let's try to go past this branching point, right? So we'll save this and we'll and so this point. Now in this universe, we'll say that digit 1, 2, 3, 4 branch D4 equals that. Oh, no. Copy you. And in this branch, we will say that that is not the case. Okay, so if it's not the case, then x is 0, so we don't need that. And that means x is 1. And so we don't need either of those, and we don't need that. And we don't need that. Oh, well, we might as well. Y is 25. Right? That's irrelevant. It's 26. Z by Y. Okay. So 26, and we don't need that. 5, okay. Y equals digit 5. Let's call it D5 plus 1. And x is 1, so add z to y, 5 plus 1 plus all this crap. Okay, that because x is 0. But in fact, what we have is x is all that crap. Percent 26. Z is all that crap. Divided by 26. our thing. We actually don't need all that height, do we? Minus 10. And we hit another branching point, right? And how far have we gotten? So that was only 20 more lines to do all that work. So we could have up to 8 more branching points, and it's really starting to get on my nerves. What are our options here? We could keep doing this by hand, and it's taken me, over 20 minutes to do this. And the original 252, yeah, and we've only done like a third of it. So it would take another 40 minutes to get through it, and that's not even considering the branches, which are starting to occur. So let's take a different approach. If we considered, if we did represent all these things as algebraic expressions, right? And that's what I was kind of working on. If we had an expression, an expression can be an add of two expressions. Indirect case. See, this is just my mind wandering. I can't even. And. Right? So. It's a constant or a digit, which is a which also takes an int. Now, okay, and then that's not how cases work. It's a colon for historical reasons. Okay, so okay, so what else are our things? Input add. Okay, let's go back to our do we ever have is there ever a constant in the first place? No, there isn't. So let's not worry about that. We only have to worry about constants in the second place. If I equals what was I saying? It's L. Then we have a constant. So, um, okay, and we are gonna have, oh, or okay. Let's actually make this a dictionary. Why not? Var. Our registers is going to be come on. What did I do wrong? No, it's working. Okay. And let how do you do a let case statement? If let there's a way to extract something. Anyway, so something about R's of L1, right? Bang. So, yeah. Well, R's of L of 1 is going to get some new value, right? And the point is, so what is in Swift? Swift, if let case expression. Swift if case let. Here we go. You can also I don't know. If case let. This is it. If case let. Rewrite the switch. Equals result. That's the weird part of this syntax. If case let constant of constant v is R's L1 bang. Then no old val. Then the ba 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 plus OV plus I, right? No, it's going to be then V equals OV plus I. Yeah. Else. Oh no. Equals. V. Actually, this is totally unnecessary. But we can say this is an add of RSL1 bang and constant of I. Right? If that's a constant, and if it's not, then no, or what is it? Case let constant value 2 RSL2 bang. Does that not work? Okay. V2 is L2 equals digit or else it is R sub L2 bang. right? Okay, so now if um, constant I2 equals V2, then R's L1 equals I mean, I guess we could have done this with a conditional, but L1 add L1 bang and what V2, right? Oh, because I didn't close it. Okay. And we're done with that case. So, assuming that is correct, quite the assumption. Well, let's check if it runs. We're going to hit our assertion pretty quickly, aren't we? Oh, good. Let's fix all these syntax errors that BBEdit wasn't catching for us. Okay. Of course. Oh my God. Lines map. Split. Just stringify everything. Just do it. Okay. Anonymous closure argument not contained in closure. Well, yes, I can see how that could be a problem. For lines, map, 0, split, map, string, 0. So that's closing that one. That's closing that one. Pattern matching in a condition requires the case. Okay, we need a case let on line 28, I guess. And of course, map. So which one do we need to parenthesize? Both of them? The first one, the second one? I don't really. So we asserted. Oh, I guess it was maybe both of them need to be parenthesized to get rid of the stupid warning. And this is just our assertion, right? Yes. Okay, so let's just make the brilliant assumption that that's good, and we can do the other. So add multiply divide mod. Add multiply divide mod. multiply. Okay. But we're going to do something slightly clever here. Okay, if okay, it's down here. So, if let constant I1 SL1 equals 0, then we do something. I don't know why I'm doing it this way. Just because it's a little prettier. Case 0, case 1, default. Oh. And we'll do that for if and we will do the same thing there. And otherwise, we'll just do the general thing, right? Why? Oh, because... Okay, so in the case of 0, we're not getting rid of all our redundancy because what's the point, right? Okay, then RSL1 L1 and it gets a whatever the v2 is, right? Okay, this is different because well, we're switching on a different thing mainly. If we're multiplying by 1, then it gets then we just break it. Otherwise, we do our thing, right? That's a constant. Okay. Else we do. Okay, what's our problem here? Is that it? Okay, so we did our mul, and we need a div and a mod, right? And Insertion failed, yeah. Okay. So, should we eliminate divide by ones, I suppose? Right? So in fact, and what about mod by 1? What do mods look like? It's always mod 26, I guess. So let's not bother with anything interesting. Well, actually, let's check with the divs. Yeah, we have divide by ones, and let's eliminate divide by ones. Okay, so, what are we doing? So we're copying the mols for the divs. Oh, we are actually doing something very bad here. That should be a mol. Instant. Mol. Oof. Including errors like that is not ideal. So this will be our div body. Big chunky div body. Okay. Oh, and that's plus, and that's times, right? So, they're both constants. We divide them. Case 0. No, that's 0. So if the first one is 0, then yes, we get a constant of 0. If the first one is 1, we get v2. Oh yeah, so it all works out just as well for the first case. So we do a div. If the second one is 0, then something bad is happening. If the second one is 1, yeah, then we break just as before. And this is just a div. Otherwise, we just build ourselves a div. And then mod, we're not doing any of that brilliant optimization. If mod. Okay, let's see if this compiles and then asserts. Yes, good. That's exactly what we want. And our last one is EQL, right? Oh, so what are we doing here? Well, this is where the branches happen and so forth. And we're coming up on an hour. Should we think this through or should we leave this for the morning? Because this is where it's going to take a little bit of thought to figure out what we're going to do. Yeah, this is the point at which, because, I'm doing this for fun, and the last few days I'm going to keep with the tradition. I'm going to say this as far as we're getting tonight. So if you're interested in how we actually use the code we've written to solve it, then watch the next video, which I will record and post tomorrow morning. Yeah, this is not particularly good television, but it's the way I'm doing it. So do watch that tomorrow because I think we're getting somewhere with this. So, see you then.